let's start with problems then from, still wrapping up with the derivative stuff. So I know we dabbled in some of them yesterday. Mary, what do you got?
75. I think we started this one yesterday.
Which one was it?
It was like definite integral from like 2 to the natural log of
Oh, yeah.
2x.
Okay, so we have a function, I think they call it f of x,
Yeah,
right?
f of x equals
The integral from
Integral of-
2 to the natural log of 2x.
yeah, and then t plus 1 dt.
T plus 1 dt. Okay, so before we do this, let's do a little review over here on the side. Let's suppose I gave you the following. What's that equal to?
Squared. Oh, yeah, x squared.
X squared, right? Everybody with me?
Yes.
Yeah, we call it the variable replacement. We're taking the derivative of an integral, they cancel each other out. T's become x's. Done. Next scenario, what if we take the same thing? And we change the top limit of integration to x squared. X to the fourth times 2x. Why is there a 2x there?
You got chain on this.
Very good. And again, depending on how you want to look at it, we did technically chain on the derivative of that here, but it's just 1. Okay, good. So we're good there. Let's look over here. Back to the blue. I think we want to find f prime now, right?
Yeah.
Okay. So what does that become?
L on 2x.
I'm sorry, what?
Our natural log.
That's what I thought you said.
2x
Natural log of 2x
plus 1
plus 1.
times.
Good. So there's going to be a times there because now we have to chain on the derivative.
2 over 2x.
2 over 2x, which is just
Or x.
1 over x. Yeah. Good. Done.
Okay.
They're not expecting you at this point, because this was still derivatives, they're not expecting you to be able to take the integral of t plus 1 and then plug in all that other. Could you have done it that way? Yeah, you know how to take the integral of t plus 1. You get 1/2 t squared plus t, then you plug in natural log of 2x, and you plug in 2, you simplify it. Yeah.
Can you go over 72? Wait, Mr. I have a question on that.
Yeah?
So if you're not doing a variable change and you still have your limits of integration that have like x squared in it, you still have to chain on the 2x? If it's just asking you to take the integral of it.
No, because those are two different processes.
Okay, so only variable.
Yeah, like I said, we could have done this the hard way and done, done this. And said, okay, big parentheses here, now I'm gonna do all this business.
Okay.
So I'm gonna do t squared plus, 1/2 t squared plus t, and evaluate that from the natural log of 2x, from 2 to the natural log of 2x. Plug in natural log of 2x, simplify, plug in 2, simplify. Then when I get done with that big monster, take the derivative of that.
Okay, that's a little ugly though.
On the AP test, they will not, very seldomly if ever, will they ask you to do a problem like this, a variable replacement problem, where you know how to take the antiderivative. Most of the time, you're going to get a problem that's so nasty that you're not going to know how to take the antiderivative. Okay, because they don't want to test your antiderivative skills, they want to test your knowledge of the fundamental theorem of calculus. All right, Kev, what do you got?
Okay.
72.
72.
Which is?
Y equals natural log, absolute value, secant x plus tangent x.
What are we doing with that?
Derivative.
Keep running the derivative.
Derivative.
Yeah, it's derivative.
Okay.
Yeah.
So I'm taking the derivative of a natural log, right?
Yep.
All right. Which means this is still going to be the old u prime over u. So I need to take the derivative of this stuff first, and then put it over itself. So I'll do that first. And then on the top, I have to take the derivative of that thing. What's the derivative of secant plus tangent?
Secant tangent plus secant squared.
1 Secant squared, you said?
Yeah.
By the way, do I need these absolute value bars here?
Yes.
No.
No. Remember, when you're taking derivatives, you don't need them.
Oh.
Yeah, right, we talked about the difference between taking the derivative of this versus the derivative of that. That was that big, long discussion the other day. With derivatives, you don't necessarily need them, so they go away. Can that be simplified? Well, I can take a secant out in top, and that's not a bad habit to get into, is at least factoring out a common term. Oh, well, look at that. It's almost like we planned it that way. Whoopsh, whoopsh. Hey, remember yesterday when we did integrals? What's the integral of secant? The natural log of the absolute value of secant plus tangent. So that's all we did. We just proved that. We confirmed what we learned yesterday in that orange chart by doing the derivative. What else?
87. Use implicit verification to find an equation of tangent line to the graph at the given point, and it's
Okay, stop. I need a tangent line, so I need a point and a slope. Okay, now I have a function.
x plus y minus 1 equals ln.
I'm sorry, equals what?
Natural log
Uh-huh, so I thought you said of.
x squared plus y squared.
Like that? Okay. This smells like implicit.
Yeah.
Yeah,
So-
so like, it does say use implicit?
Yeah.
So it even includes you in, didn't even expect you to figure that out. And we're looking for a tangent line. Does it give you a point too?
1, 0.
1, 0. At 1, 0. And depending on the problems, we've seen a variety of problems here. Sometimes they'll give you the actual point. Sometimes they'll give you the x value of the point. Expect you to find the y value. All right, so what am I going to do? I got a point. What do I need?
Slope.
Slope. How do I find the slope?
Take the derivative.
Good. Quick refresher on implicit differentiation. Here we go. What's the derivative of x?
1.
1. Derivative of y? Y prime. Derivative of -1? 0 goes away. Right hand side, derivative of natural log. As soon as you see derivative of natural log, you think
U prime over
u prime over u. Derivative of this?
2x plus 2y, 2y prime.
Okay.
Uh-huh.
Now, you could say to yourself, I need to get y prime by itself. In this case, I wouldn't even bother.
Okay.
I would just plug and chug and hope it simplifies nicely. Because it doesn't say find the function, it just says find the tangent line, so all we need is a slope. 1 plus y prime is equal to 2 plus, that goes away. So there's no plus there. And then that goes away, we're left with 1. So it looks like y prime is equal to 1. Yes or no? Good.
How'd you do the 1 plus y prime equals 2?
I plugged in the 1 and the 0
Oh.
because we know where the point is. So instead of going through all the algebra of having to solve for y, because I have to bring this over, distribute it, and
Oh.
plug and chug. Y is equal, no, yeah, y minus 0 is equal to 1 times the quantity x minus 1. Hopefully that's the right answer. Yeah. And if you're feeling saucy, you wouldn't even have to put the parentheses around it. Anything else with the derivative stuff before we dive in? Yeah.
93.
It's getting awful close to 100. All right, what are we doing 93?
Y equals x times the natural log of x, and then I think it's finding the relative or the extremity, right?
Yeah.
Is it the extremity?
Beautiful.
First root.
So let's forget about this function. Let's just talk about how to find the relative extrema. How do I do that? Then?
Test the critical
Okay.
number.
Good, find critical numbers, put them on number line test region, up, down, up. Okay, good. So we need derivative first. How do I do this derivative?
How do you do it?
Chain rule, or no, product rule?
That was integrals.
Oh, integrals?
Yeah, that was integral for this guy.
Product rule?
Product rule, right. Okay, two different functions there. We got x and natural log of x. So first times derivative of the second plus derivative of the first times the second would give me that, which is just 1 plus natural log x. Set it equal to 0. So the natural log of x is equal to negative 1. What's that?
What do we do next?
Say again once more.
What do we do next?
Great question.
Inverse natural log.
Find the inverse natural log?
No.
No such thing.
That's the
But we'd like to find x. You can do it a couple different ways. You can use your calculator, plot the natural log, and see where it's equal to negative 1. I don't know if it's a calculator problem. Let's pretend it's not. Go back to our sneaky little tricks you learned in pre-calc. I'm assuming you learned the E2 trick?
Oh, yeah.
Yeah.
I remember.
Yeah.
Learning that. I don't know what it is.
If you didn't, you should have learned the take the natural log of both sides trick or the e to the trick. So this is 1 over e. What's e raised to the natural log of x? X. Just for an idea, well, let's put that on number line then. This is a y prime number line. Just so things don't get out of control, about how much is 1 over e? Well, what's e? Can you do them all?
2.718, 2,
Keep going.
828,
Yeah,
1, 828.
right, because you ran for 2
Yeah.
terms.
So 1, 0, or
3, 45, 90, 45.
90, 45.
45.
45, 90, 45.
Is 3 before that or after that?
There is no
Oh, I
3.
thought there was
18.
So if e is about 2.718281828459045, then what is 1 over e about?
1/2.
It's about 1/2. So we want to pick a number, when we're picking a number to the left and to the right, we want to make sure that we get good numbers in there. What would be a good number to pick over here? Negative gabillion? I don't know if I'd consider that a good
0.
number. 0 would be a good number. Yeah, I like 0. So if x is 0, what's the derivative equal to?
0.
No.
I'll add it.
Uh-oh. Maybe 0 wasn't a good number to pick. What's wrong with this number line?
Doesn't the natural
Correct, and there should be some parameters.
The graph in natural log starts at 1, doesn't it?
Starts at 0.
Zero, positive.
So we can't plug 0, because remember the graph of the natural log is asymptotic to the y-axis. So we got to pick something between about 1/2 and 0, so maybe 1/4. If I put 1/4 into this, I'll get a negative number. I don't know how big of a negative. Somebody tell me what the natural log of 0.25 is, please. I'll eat this desk if you read that. If you nailed that to 3 decimal places, I'm leaving.
It's not that big.
Negative 1.38.
Oh,
God. So this is negative, going down. And then 1 would work nicely here. The natural log of 1 is,
1 over M.
natural log of 1 is 0. So this will be positive. Okay, so what do we know? Because
Y prime goes from decreasing to increasing.
no. Y goes from decreasing to increasing. Y prime goes from negative to positive.
Negative positive.
It's been a while.
And is that all we had to do was find the extrema?
no, you gotta do the, you have to, POIs. Points of inflection.
Yeah, I know what this is.
Person of interest.
Yeah. Okay, wanna keep going then?
No, I don't care.
I don't know, sure, alright, y double prime?
Can you go over the E thing again?
What do you think?
The double E trick. So when you have a natural log, do you just take, can you take the natural log of both sides too?
Yeah, that's another trick, you can do anything you want to both sides of an equation.
Okay.
Okay, what's y prime here? Y double, oh, this is easy. Y double prime is 1 over x. Change colors. Zero. Uh-oh. You understand my problem?
Yeah, it's a third.
Are there no points?
Doesn't seem to be. Because my only critical number for y double prime would be at 0, and 0 is at the end of our domain, and therefore you can't test the left side or the right side, so since there's nothing on the left-hand side of that, I would guess there's no points of inflection. Hopefully that's correct, yes?
The answer key says, it's like
Oh, here we go.
e to the negative 1 in the x, and then y is negative e to the negative 1.
For the extrema,
I don't know.
does it say anything about a point of inflection? Good, then I'm right, let's move on. Pretty good.
In the second step, why did you add plus natural log of that?
Oh, product rule. So, first times derivative of the second, derivative of first times second. Okay.
That's the derivative.
Oh, you said you didn't have to know that.
You got one more?
Yeah.
Alright, then we'll move on to integrals.
Okay. 89.
Uh-huh.
Show that the function is solution of the differential equation. And then it gives you the function y equals ln x plus 3, or natural log of x plus 3. And the differential equation is x, y double prime,
X, Y, double prime,
plus y prime
plus Y prime
equals 0.
equals 0. Are you understanding what the problem's asking you to do?
No.
Okay. Anybody else? What's the problem asking us to do here?
Find how like that equation's equal to that one, or
A little more explanation. Yeah, you're on the right. What's that?
Just try to prove it, right?
Yeah, that's what I'm asking. What does that mean?
Like, when you solve y prime and y double prime, they should equal 0. When you plug it in.
Okay. Find Y prime, find Y double prime, plug it in, make sure it equals 0 when you stick an X in there too. So first we need Y prime. What's Y prime, Sam?
1 over x.
What's Y double prime? Ooh.
Quotient rule,
You could do quotient rule if you'd like.
or wait, no,
Or you
x
could.
to the negative 2, so 1 over x squared
Good. You missed something though.
plus c.
No.
No, wait, that's backwards. Sorry.
What is it you always shout out? Limit, Kev?
Yeah, the limit.
Limit. If plus C doesn't work, then use
Yeah.
limit.
I mean, I also.
You changed it though, didn't you? What do we?
It
What do we
goes
do?
away.
Shout out.
It goes away.
Now you do plus C.
Well, yeah.
Okay.
Yeah, that was first semester.
Mr. Eden, the new one is it goes away.
Yeah, well, yeah, and it goes away.
Did you see why there's a minus sign there?
It just happens. The ease.
Because if you did the quotient rule, it would.
That's X to the negative 1. Bring the negative 1 down.
Oh, yeah.
Oh, I wrote down wrong.
So that means we get X times negative 1 over X squared plus 1 over X, and we're wondering if that equals 0. That's X, oh, yeah, that looks like 0 equals 0 there. We are good to go. Okay, good. Staple both days together and pass those forward, please. Oh, I'm sorry, what? You said that like a fraction too late. I'm sorry?
I'm confused. I got the second derivative. I got that.
1 over x.
Wrote it as X to the negative 1.
You what?
Wrote it as X to the negative 1. And then bring the -1 down, reduce it by 1.
Say it's stable.
Yeah, please staple it together. You got more than one page, which I think you would.
Like stable 78 and 79.
Together.
Okay.
Put your name on it, and then pass it up. Is everybody that's missing today a junior, or are we missing any seniors?
He's like insanely sick right now.
He's doing pretty good.
Where is he, Dennis?
He's like really sick right now.
You'd still be here.
He's at the hospital.
Really? Hospital sick?
Yeah, that's the
Oh, what's he got, malaria?
Kidney stone. Yeah, probably, kidney stone's got
If he was Sam, he's still coming to school though. If he's Sam, he's still here.
Yeah, you're suggesting kidney stones are now contagious?
Yeah.
Just going around, everybody's getting them now.
No, Mr. Eden,
Hey, can I have you drink your water? No, I don't wanna get your kidney stones.
in my chem class, it goes in a row. Two
Yeah,
people
yeah,
right
yeah.
next to each other, and Dennis is next. Dennis is next in line for the kidney stone.
Is Colin?
Dude, you haven't lived until you pass a kidney
Oh,
stone.
It's
It's life altering.
I've been drinking
I
water
don't wish
that
that
worse than
I drink like 10 cups of water a day, so
I had
you gotta eat
a,
vegetables.
I had a friend that literally had his finger ripped off in an accident, and he said that pain was nothing compared to passing a kidney stone. He said he would have the other 9 fingers ripped off the same way versus passing another kidney stone.
I'll say this, Jesus.
Because I had 2 people
Kyle took the easy way out.
No, Kyle couldn't have passed it. It was too big.
I know.
It was the size of a pea.
It was 6 millimeters.
Aren't like kidney stones like for older people? That's how
Yes, older people.
Can we still get our high five though?
Yeah, like how does Kyle have?
It's only, we have a.
You all have
No,
one.
how do you get that?
My paper's so
Yeah,
small.
Mr. Eden, I don't isolate myself. Yeah.
Like-
Just had
Yeah.
Okay.
I don't deserve that.
I mean, I know. Maybe that was a key on that too. Yeah.
Casey, do you have
You're
your
all
own?
at high five.
Yeah.
Moving
Oh,
on.
wait.
Oh, wait.
Where I,
Oh, you have it?
yeah, where is it?
I don't know.
Oh,
Oh.
wait, did we pass it out there?
Yeah, I'm all.
I mean, John's technically not in this row, so we should.
Oh, you're
He's
in.
for today though, but.
Sam,
Billy
he's in your
just joined
row.
us, yeah.
He's in our row. We don't get high five.
No, I'm just gonna move
Me and John. Me and John need to get in the same row so we don't ruin people's days.
Okay, let's talk about some integrals then.
Nobody gets it.
Mary,
27.
go ahead.
The integral sign.
Yeah.
And then.
The,
one-
wait, what do we call that? The Archimedes symbol? Uh-huh.
1 over 1 plus the square root of 2x dx.
That?
Yeah.
What are we doing with that?
I think it's fine the integral. Or like, I don't know.
There's gotta be something else, because I don't think that's gonna work out. Is it the square root of 2x or the square root of 2x? Are there parentheses there? Is the x underneath the radical symbol?
Let me pull.
I think that's the right one.
It's underneath the radical symbol.
It's pretty wild.
You can't do U to U, right?
No.
Can't be negative.
Oh, I tried to use you.
Hold on, I got my book too, I'll look it up.
Yeah, you have to find
No, you
the
can do
indefinite
U.
integral by u
U equals
substitution.
1 plus 2x.
Yeah.
Hence, let u be the denominator under the integral.
Yeah, you could
You
just
can
do
do
1
U to U.
plus root 2x to the negative 1. But
What number is that?
27.
Okay. Okay, let's see. This will cancel, that makes our lives easier. And this is 1 over square root x dx. equals du, so square root of x du is equal to dx. Oh, this is I don't know why I assigned this problem. Okay, so if we do a substitution, this is where things get a little crazy here. Oh, wait, I can't cancel that 1/2, can I? Because isn't that underneath the,
Yeah, that was the exponent.
right? So this is, well, if I bring that down, I take that, then this is this way, so I can't cancel the 2. So the 2 still, you can't even see this, hold on. I put the 2 back in there and put a 2 in front of that. Okay, so this is where I think things are gonna get a little crazy. I think what we need, because now things won't cancel.
Yeah.
But I think what we can do is write this as, if this is equal to that, then the square root of 2x is equal to u minus 1.
Cheeky.
I know, I'm embarrassed I assigned this problem. I'm not embarrassed, but it's just,
I'm never gonna.
yeah, this
rude.
is gross. Okay, so if I do that, let's see if I can get the substitution to work. So this will be 1 over u, and then this mess becomes, there's a 2 out in front, that's that 2, and then this will be u minus 1 du, which is 2 times the integral of u minus 1 over u du. Again, I apologize. That's horrible.
Would this be on like quiz or test?
Probably not. Of course,
It's
now
fair
that
game.
now
Everything's
we've covered it, it's fair game. Let's talk about how to find the integral of that now. How do you find the integral of u minus 1 over u?
Plug in you.
Nope.
U over u minus 1 over u.
Yeah, split the fraction. So this becomes 2 times the integral of u over u du, whoops, u du plus the integral of 1 over u du. I knew the natural log would come in here somewhere.
Wouldn't it be minus?
It would be minus, thank you.
We just need this problem, right?
This is one of those crying problems. Okay, that's.
You should just have this up on the board tomorrow to scare the juniors.
No, I should just hand out a quiz. The quiz should just be this problem. One problem, just hand it out, and then everybody's quiet, and you guaranteed they'd be like this. Then the juniors would make eye contact with each other.
And then just get up and leave.
Yeah.
Be like, I'm going back to the PSAT.
I'd rather take.
Give me the SAT again, please. Okay. I'm assuming you do it from there.
Wait, is this?
Okay.
Yeah, this is one of those weird, nasty type problems.
Okay.
I mean, yeah, it's calculus, it's talking about what we're doing. Would you see that on the AP test? Probably not. That's a little, well, you know, you might. Now, where you would see this on the AP test is there's some problems where they have like A through D. And so a lot of times what they'll do is they'll test, the A part is ridiculously simple, then B gets a little more aggressive, and C gets a little bit, and then D is like, is that even English? This would be an example that they would throw that into D to make you know, basically they're trying to test the difference between, is this a 4 or a 5 paper? And maybe you could get partial credit for being able to recognize that that's a U minus 1, or you just leave it blank and you get 7 out of 9 on that problem.
I don't want to 5.
What else? Sit.
58.
Uh-huh. Here, I got that. Oh, I'm sorry, I'm laughing because this is another sleazy one. I'm sorry. Yeah, okay, I'm just gonna preface this by saying you're not gonna like this at all. You're gonna be angry with me, and again, I apologize, but you should be exposed to this. So what did you try? Let's talk about that first. Let me try to make you feel better about this problem before I ruin your day.
I don't think you can.
You can't, you just, right, does not exist. I mean, you can't choose the denominator as u, cause nothing will cancel. You can't choose the numerator as u, cause nothing will cancel.
And you can't split it because.
Can't split the fraction cause x over x plus one doesn't work, and negative one over x plus one doesn't work. Again, I apologize. And there might be another way to do it. I did it this way. All right, here we go. So what I did was, I rewrote the top.
No, stop it. Stop it.
I'm sorry.
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 Wait, no, where did we?
So then it's just, so you then just split the fraction?
Wait, where'd you read that?
Magic.
X minus 1.
Again, maybe there's another way to do this. This is all I could come up with. So I turned negative 1 into 1 minus 2. Why would I do that? Yeah, so now I can split the fraction.
That's okay.
You just created.
You just made math. You just made math.
Where's this been my whole life?
I think it's the
We'll see.
Is this gonna be on our test?
Yes.
It's muy malo. Are you good from that point?
Yeah.
Yeah. Because you get, notice the first one is just, that's gonna be easy. The second one you have to do is a u du, and then you'll end up with a natural log in there. Everybody, I guess I assumed too much. Does everybody see why that second one would become a natural log? I'll take your lack of, let's just do the second part, okay? Okay, so remember yesterday I said a common mistake is people take 1 over anything and say, well, that's just the natural log of that. This is a case that kind of proves me wrong there, where I didn't really need to do the u du, because the function works out such that its derivative is just 1. That's not going to happen very frequently. So you got to do this every time. Evaluate that from 1 to 0, evaluate that from 1 to 0, and subtract the 2. And you might get some answers because they're not expecting you to know what the natural log of 2 is off the top of your head. Your answer will be in the form of a natural log. Because notice this will be 1 minus 2 times. If I put 1 in here, I get negative 2, if I put 1 in here, I'll get the natural log of 2. And if I put 0 in there, I get the natural log of 1. What's the natural log of 1? 0. That one you know. So there's your final answer. So maybe it is a good idea that we finish that. We got her.
Number 47.
God, I hope it's not another. Let me
Deter-
look. I think this one's pretty reasonable. I think we can do this. Is this, they give you the, oh, okay, yeah, this is what we call a differential equation. Is this the one that starts with the f double prime?
Yeah.
Okay, f double prime of x is how much?
No. Or 2 over x squared. When f of 1 equals 1, f prime of 1 equals 1, and x is greater than 1.
Okay, so we're gonna find
Or
f
zero,
prime.
wait, 0, it's x is greater than 0.
We're gonna find f prime. When we find f prime, we're gonna have the c term. This will help me get rid of the c term, not get rid of, but find the c term for f prime. Then we'll do it again and find f. We'll have a new c term. That'll help me get rid of the c term. Okay, so the integral of f double prime will give me f prime of x. And this is 2 times the integral of 1 over x squared dx. Let's make u equal to x squared, so du is equal to 2x dx. So dx is equal to 1 over 2x du. What am I doing? You were just gonna let me go, weren't you?
Well, I didn't really.
Yeah, whatever. Holy guacamole. All right. This happens. That's better. This we can do. That's not a natural log problem. So raise it by 1. -2 times x to the -1 plus c, which is -1 over x plus c.
Where did the 2 go?
What 2? Oh, it disappeared. What 2? This 2?
Yeah.
It's right there. What are you, blind?
Yeah.
Okay. So what's x?
1,
What's
or
f prime?
1.
1. So put in 1 here, put in 1 there. So c is 2. Nope, 3. Sure, I can do calculus, I just can't add. Which means this is -2 over x plus 3. That's my new f prime. Repeat the whole process. Should we keep going?
That's fine.
You sure? I'm having fun. Or we can stop.
We can keep going.
Keep going, sure. Or we can stop. F prime of x is equal to -2 times x to the -1 plus 3. Take the integral of that, take the integral of that. So this will be f. And oh, now I got to do a natural log here. So that's -2 times the natural log of the absolute value of x. Oh, hey, do I need the absolute value bars here?
Yes. No,
Why? Other than I shook my head no.
I don't know.
X is greater than 0.
Oh.
X plus 3x plus, we could use c again, you could change it to d, you could do whatever you want, we'll just stay with c. This one's the red c now, the other one was a blue c.
The right C.
Plug in 1 for x, plug in 1 for f of x, solve for c, you get your final answer, put it all together in one happy little equation for f of x, Cameron.
For the x plus 1 over x minus 1, not this, the last problem.
Yeah?
Can you not do like a chain rule, quotient rule with that?
It's an integral.
Oh, okay. I thought we were gonna do that.
Good? Kev?
I'm just confused. How did you get that -2 natural log x from the first term?
Okay, good. Let's do this. -2, 1 over x plus 3 dx, plus 3 dx. Okay, so now we're taking the integral of 1 over x, which is what we did yesterday.
Which is just x.
Yeah. And the mistake I made when I started this mess is I saw 1 over something and I went all, turned into like JoJo the Circus Boy and started doing a natural log when in fact that's just x to the -2 and it's what we did months ago. All right, beautiful. We're done for the day. So I got another day of integrals tonight, and then tomorrow we'll talk about the next lesson. I'm not really sure what the topic is. And then the quiz will be on Tuesday after a 3-day weekend. That'll give the juniors time to get caught up and give you guys